All right, folks, I'm going to talk you through some initial work that we are going to be doing to process streamflow time series. And we're just starting by looking at one time series today. And so what I'd like you to do as you start this video is navigate to Moodle. You're going to navigate to our weekly homework assignment. You're going to download 4 files. You are going to download this data set. I'm going to navigate back and download 3 M files next. So we've got one here, download. Close this and navigate back. One here, download. Close and navigate back, and a third. Download. All right, so what you're going to want to do is navigate to your downloads folder, and you're going to want to find your thumb drive, hard drive, whatever you're using. And I'm going to plug mine in now. And just navigating to my desktop, grabbing my Finder or File Explorer if you're on a Windows computer, and then you're going to go to your downloads folder, wherever that might be, and you're grabbing these 4 files that you've just downloaded. I'm just going to copy them, and then I'm going to go down to my drive. I've got my CE352 folder, and we're going to start by making a project 2 folder. Believe it or not, we are already starting project 2. You're going to make a new folder and go ahead and call it let's call it time series. And you're going to paste your 4 folders, 4 values in there. All right. All right, so we've got our 4 files here, and our next step is going to be to open MATLAB. So however you do that on your computers, go ahead and open up MATLAB. Okay, once MATLAB is open, you want to navigate to that folder where you just saved your materials. Mine has ended up in some weird spot. That's okay. I'm going to my drive, CE352, project 2, and my time series folder, and I'm going to say open. So we've got a couple pieces of information we see over here. When you see the little f of x symbol associated with an M file, that tells you it's a function. So we're going to be talking a little bit about functions today. Go ahead and give me a new script, not a new live script, just a new script. And I'm adding a clear all, close all at the top. You don't have to, I like to. And I'm going to save this. And I'm going to save it in that folder. And I'm going to call it process. Site 1. Let's go ahead and call it homework 5. So we're going to be working with these functions today, and we're also going to be working with creating functions. You have learned to import data. So go ahead and come back to your main screen. You're going to click on import data. And I'm just going to show you really quickly. You can say open. We can get a view of our imported file. And it's a large text file. We've got some names. I'm going to change the name for this. It was read right out of the USGS. This is Q in CFS. I'm going to change that name. We also have Q in millimeters per day. We have the watershed area in square miles, the latitude, the longitude, and the site number. And you all remember we can change the output type to column vectors, and we could come over here and pause, don't follow along right now, just pause and watch. And I can say import selection, and it will import that data for me, and it'll appear the way it always has over here. However, we are going to be working with a large number of files for this project. So instead of importing one file, we want to have a way that we can import multiple files. So what I'd like you to do instead, come back to your screen here, clear, because we want to use that to verify we can see what's happening. And you're going to click down here and you're going to say generate function. And what that does is it creates a function. If you give a file name, you get out all of those columns of data. And if for some reason you're not seeing multiple outputs here, it means that you need to go back to your import selection and change your output type to column vectors. So I have a function. I am going to save this function. I'm going to go to save as. I want it to be in that folder. And I'm going to call it import USGS Q. And I do that, and all of a sudden, import file chain gets angry at me, right? It's telling me, hey, it knows this file by a different name. I'm just going to click fix, and it's going to update it. And I'm going to say save. I am going to copy this whole line, and I'm going to bring it over to my M file. I'm actually going to get rid of data lines. If we don't fill that in, it just brings in all of them, which is great. And it's referencing something called file name. So I got to give it a file name. And in this case, I want to give it the name of my CSV file that I'm trying to read in. So if I type Q15, if I type the name, right, Q15 data underscore 1.csv. Let's say I just try to run it. I'm going to highlight it, highlight and say evaluate selection. It doesn't like it. It's like, what the heck is this thing? That is because we need to tell MATLAB that it is a file and it's a file name. It's a word or what we call a string. So we want to add little single quotes around it that turns it purple. And all of a sudden MATLAB recognizes this as characters. And so over here in the workspace, I now have this recognized as 13 characters. So again, we can always run mat lines one by one. I'm going to rerun that file name, right click, say evaluate selection, and I'm going to try to run this file and I'm going to say evaluate selection. And if it works, you should see everything right in your command window. So we have brought in a file. Where we are working towards, just to sort of prep your brain, is we want to write this in a loop. Eventually, we're going to be bringing in a bunch of different files and processing them, but we're just processing one for now. So we have a function. What is a function? When we run this, it executes this separate M file, a function, to import Streamflow, our Q data. And so this is a separate M file, and there's all sorts of information contained in this function, but we don't see it. We don't see the processing of it. So it's a way to make our scripts more efficient. It's a way to have layers and different components to that. So let's start doing some stuff. So let's plot the data first. A good step is to always plot the data. And we've got my dates and QMM per day. And again, I'm just going to select it all and say evaluate it. Or you can run it. And this is our project where we're going to be looking at trends through time. So you have a long data set. You can always use this to zoom in. So let's see where we start. So we start before January of 1971. probably on October 1st of 1970, meaning we have the 1971 water year. And we go to, let's zoom over here, October of 2021. So you have approximately 50 years of data. We have 50 years of data. I am going to delete that because I've looked at the data and I feel good about it. I'm going to have you make two different files today, do two different sets of processing. One is called a flow duration curve, and we're going to make this for the entire data set. So I am typing some code that I'm hoping you follow along with. I add the figure command, and what this means is I open a new figure. This line set GCF color 111 sets the background of that figure to white. And what I'm going to do is plot a flow duration curve. And what that means is I am plotting stream flow as a function of exceedance. We are going to talk more about this in class, but I want you to see it in code first. So I am going to create an exceedance probability, and that is the rank of all of my streamflow values from greatest to smallest. To develop that, I need to go from 1 to the length of my data set, 18628. And I'm going to divide that by the length of my data set, 18628 plus 1. I am last going to multiply by 100. So if I evaluate this, what I get out is a ranked data set going from very low numbers to nearly 100% at the end. So in hydrology, a lot of times we don't look at things in percentiles, we look at them in exceedance, which is just sort of flipping percentiles. We are going to next sort our streamflow values. So I am going to say, grab my QMM per day, and I'm going to say sort it. And I want bigger values first, to smaller values, and I'm going to run this, and I'm going to look at Q sort coming out, and it starts with really tiny values and goes to bigger values. That's not what I want. So let's take a look at the sort function. You can always type in help sort. And as you look through this, you're going to see, oh, here's something that might be useful to me, the direction. So ascend sorts in ascending order, that's the default. But I can also sort in descending order by using this command descend. So I am going to copy that command, add a comma to separate it, and I'm going to run that again. And let's take a look. Now I have the big values first and the small values at the end. Awesome. So I want to plot these two values. I want to plot the exceedance probability on the x-axis and sort Q on the y-axis. And I am going to move this code above my figure just for later. And let's run it. And when we run it, we get a flow duration curve. And a lot of times for flow duration curves, and even for plotting hydrographs, we will plot the y-axis as a log transform. It helps us highlight the different values. As you see on this plot, we have a lot of really big values, but we're not really seeing the values down here. It's harder for us to compare things. So there's a couple different ways to do this. This is one way I know. It's telling you, hey, grab the axis, change the y scale to log. And there's other ways to do this. You can check your sheet. So if I highlight all of this now I have what looks much more to me like a flow duration curve. One of the things that we might extract is a slope of the flow duration curve. And it would be between the 33rd and the 60th percentiles or other parts of the flow duration curve as well. So you've made your flow duration curve. Last but not least, we are going to calculate a baseflow index. And to do that, we are going to use this function sig BFI. So I'm going to open it up, and it has a lot of information. I'm going to copy and paste that function over here. And I want to read what it needs as information. It needs Q, stream flow in millimeters per time step. Ours is millimeters per day. It needs T, a MATLAB date time, which we have. And then it needs a method. And there is a default method, so we're just going to use that one, which is totally fine. So I am going to get rid of that argument to pick a method and just say go with the default. And I got to specify Q and T. So I'm moving this over so I can see everything again. Q is QMM per day, and T is my dates. And I'm going to say evaluate selection. And when I do, a couple of different things happen. First is I actually get a pop-up. And what we are doing here is we are estimating base flow. We are separating stream flow into quick flow and base flow. Base flow being the source of groundwater that is contributing to stream flow throughout the year. And you can see that base flow indicated by the red line here. Anything below that red line is estimated as base flow. Anything above that red line is estimated as quick flow or storm flow, water mobilized by precipitation. So the other thing I get out is a base flow index, which is shown right over here. I know it's coming out of that code because it is to the left of that function. And I get a value of 0.6071. This is a dimensionless number that tells you the proportion of total flow coming from base flow. So for your assignment, your goal is to comment this code. So tell me what's happening on different lines. Tell me what different lines do. You can have just one line for your figure. That's totally fine. Or you can add the comments after this. For instance, here, turns background clear. Put your comments wherever, and you are submitting your comments to me, your commented code. You can just copy and paste this into a Word document. So where we are moving towards, we have calculated a flow duration curve and a base flow index for the entire period. Our goal is to do this year by year, and we are going to use loops. So stay tuned for that next video that we'll be working on next week.